Long before Sabrina Pasterski became a name associated with Harvard and theoretical physics, her relationship with knowledge already set her apart from conventional academic trajectories. What distinguishes her early life is not merely intelligence in the traditional sense, but a profound instinct to understand the world through first principles rather than instruction. From an unusually young age, she displayed a tendency to approach problems by stripping them down to their essentials, ignoring established pathways and instead reconstructing understanding from ground up. This approach, subtle at first, would later become the defining feature of her scientific identity. Unlike many prodigies whose talents are nurtured through formal competitions, accelerated coursework, or rigid mentorship structures, Pasterski's intellectual development unfolded largely outside standard institutional frameworks. She was not driven by grades, accolades, or academic hierarchy. Instead, she gravitated toward exploration, experimentation, and self-directed learning. This independence would become a hallmark of her career, but its roots can be traced back to her earliest engagements with science and engineering. One of the most widely cited moments from her adolescence involves her decision to design, build, and fly a single-engine airplane while still in her teens. This event is often recounted as a symbol of her brilliance, but its true significance lies deeper than the spectacle itself. Building an aircraft is not an act of mechanical assembly alone. It requires a synthesis of aerodynamics, materials science, structural engineering, control systems, and an intuitive grasp of physical laws. Pasterski approached this challenge not as an engineering assignment, but as a question about reality itself: how lift emerges, how stability arises, how energy and motion interact under constraint. What is particularly revealing is that she did not rely on step-by-step guides or institutional instruction. She studied flight manuals, physics texts, and engineering principles independently, integrating them into a coherent understanding. This process mirrors the way theoretical physicists operate at the highest level, constructing internal models of reality rather than memorizing external formulas. Even at that stage, Pasterski was not simply learning physics. She was thinking like a physicist. The airplane project also revealed something else crucial: a rare willingness to accept responsibility for one's understanding. To fly an aircraft you built yourself is to place absolute trust in your grasp of physical law. There is no room for approximation masquerading as certainty. This demand for conceptual integrity, knowing not just that something works, but why it works, would later define her approach to abstract physics problems where experimental confirmation is often impossible. Her early intellectual environment did not follow the pattern of pressure-driven excellence. There is little evidence of overtraining or forced specialization. Instead, Pasterski's development suggests a freedom to follow curiosity wherever it led. This freedom is often underestimated in discussions of genius, yet it plays a decisive role in producing thinkers capable of original breakthroughs. By not being confined to predetermined curricula, she avoided absorbing assumptions unconsciously. This allowed her to encounter foundational questions with fresh eyes. As she transitioned toward formal education in physics, her unconventional background began to distinguish her sharply from peers. Where others approached physics as a body of established knowledge to be mastered, Pasterski approached it as a living structure whose foundations remained open to interrogation. This difference in attitude is subtle but profound. It marks the transition from student to thinker, from problem solver to theory builder. Her acceptance into the Massachusetts Institute of Technology marked the first major intersection between her independent intellectual path and the world's most elite scientific institutions. MIT, known for its intense rigor and competitive atmosphere, has long been a proving ground for exceptional talent. Yet even within this environment, Pasterski stood out not because she followed the system more efficiently than others, but because she often seemed to operate orthogonally to it. At MIT, she became known for her tendency to prioritize understanding over performance. She was reportedly less interested in conventional academic milestones than in pursuing questions that genuinely puzzled her. This sometimes placed her at odds with the rhythms of structured education, which rewards productivity, compliance, and specialization. However, it also placed her closer to the spirit that has historically driven major scientific revolutions. Her early research interests already hinted at the trajectory she would later follow. Rather than focusing on narrow, well-defined problems, she gravitated toward the conceptual edges of physics areas where gravity, spacetime, and quantum theory intersect. These regions are notoriously resistant to progress, precisely because they challenge existing frameworks rather than extending them. That a young student would feel drawn to such problems speaks volumes about her intellectual orientation. Another striking feature of her early development is her comfort with abstraction. Many talented students struggle to move beyond concrete problem solving into conceptual synthesis. Pasterski, by contrast, demonstrated an ability to reason fluidly across levels of abstraction, moving from physical intuition to mathematical expression and back again. This ability is essential for theoretical physics, where equations are not merely computational tools, but symbolic representations of reality itself. Her peers and instructors often noted that she asked questions that reframed discussions rather than extended them. Instead of asking how to apply a known principle, she would ask why that principle took the form it did. These questions do not always have immediate answers, but they expose hidden assumptions and open new conceptual pathways. Such questioning is rare in early-stage researchers because it requires both confidence and humility. Confidence to challenge established ideas, and humility to accept uncertainty. The early phase of Pasterski's rise also reflects a resistance to intellectual branding. While many young scientists seek to define themselves through affiliations, titles, or fashionable research topics, she appeared largely indifferent to external validation. This indifference has often been misunderstood as aloofness, but it more accurately reflects a deep internal motivation. Her work was driven not by career optimization, but by an almost philosophical commitment to understanding nature. This stance echoes patterns seen in other transformative thinkers. Albert Einstein, for instance, famously resisted academic conformity in his early years, struggling within rigid institutional systems while developing ideas that would later redefine physics. The comparison is not superficial. In both cases, independence of thought preceded recognition, and internal coherence mattered more than external approval. Another defining element of Pasterski's early rise is her skepticism toward authority, not in the sense of rebellion, but in the sense of epistemic responsibility. She did not accept ideas because they were widely held or elegantly formulated. She accepted them only when they aligned with her own reasoning. This mindset is essential in a discipline where progress often requires questioning even the most successful theories. As she moved deeper into advanced physics, this skepticism manifested as an insistence on conceptual clarity. She was known to be dissatisfied with explanations that relied on mathematical formalism without physical interpretation. This is a crucial distinction. Mathematics can describe reality with extraordinary precision, but without interpretation, it risks becoming detached from meaning. Pasterski sought not just equations, but understanding. Her early trajectory also illustrates the importance of solitude in intellectual development. While collaboration is essential in modern science, original ideas often emerge from periods of isolation, where thinkers wrestle privately with unresolved questions. Pasterski's self-directed learning and independent projects suggest that she was comfortable working alone, guided by internal standards rather than external benchmarks. This comfort with solitude likely contributed to her ability to confront difficult problems without the reassurance of consensus. In fields like quantum gravity and black hole physics, there is often no clear roadmap. Progress depends on the willingness to explore speculative ideas rigorously, knowing that many will fail. Pasterski's early experiences had already prepared her for this uncertainty. By the time she transitioned toward Harvard and more formal research roles, the essential features of her intellectual character were already firmly established. She was not a product of elite institutions so much as someone who entered them with a fully formed approach to thinking. Her early rise was less about acceleration through systems and more about remaining intellectually autonomous within them. This autonomy is perhaps the most important aspect of her early story. It explains why comparisons to Einstein arise so naturally, not because of identical achievements, but because of a shared mode of engagement with reality. Both treated physics not as a profession, but as a way of thinking about existence itself. As this first phase of her life comes into focus, what emerges is not a narrative of effortless genius, but of disciplined curiosity, intellectual courage, and an unusual commitment to understanding. Over recognition, these qualities, cultivated long before fame or institutional prestige, laid the groundwork for everything that followed. And it is precisely this foundation, quiet, unconventional, and deeply principled, that makes the later chapters of her scientific journey not just impressive, but inevitable. As Sabrina Pasterski's early intellectual foundation solidified, the distinction between talent and trajectory became increasingly clear. Many individuals possess exceptional ability, but far fewer develop a coherent direction that allows that ability to mature into original contribution. What marked this phase of her development was not an increase in speed or productivity, but a sharpening of intent. Her curiosity began to narrow, not toward specialization in the conventional sense, but toward questions that sat at the deepest structural levels of physical theory. During this period, Pasterski's thinking showed signs of an unusual synthesis between intuition and rigor. She was not content to rely on abstract reasoning alone, nor did she limit herself to physical analogies. Instead, she moved fluidly between conceptual imagination and mathematical discipline. This balance is exceedingly rare, especially in young physicists, because the two modes of thinking often develop unevenly. Her ability to integrate them suggested a mind already attuned to the demands of foundational research. What becomes increasingly apparent is that her unconventional rise was not accidental, nor was it a byproduct of external encouragement. It emerged from an internal refusal to separate understanding from meaning. For Pasterski, physics was not merely about predicting outcomes or solving equations. It was about uncovering the logic by which reality organizes itself. This orientation shaped how she engaged with advanced concepts long before she encountered them formally. As she encountered more sophisticated theoretical frameworks, she displayed a marked resistance to intellectual complacency. Rather than treating established theories as endpoints, she treated them as provisional structures, useful, elegant, but incomplete. This attitude placed her in quiet tension with the dominant culture of modern physics, which often prioritizes refinement over revision. Yet it also aligned her with the historical lineage of thinkers who reshaped the field by questioning its foundations. Her engagement with ideas surrounding spacetime and gravity reflected this mindset clearly. Instead of approaching these topics as technical domains governed solely by complex equations, she approached them as conceptual puzzles. What does it mean for spacetime to have structure? How does information behave in extreme gravitational environments? Why do symmetries appear to play such a central role in physical law? These questions are not easily operationalized, but they are precisely the kinds of questions that precede paradigm shifts. One of the defining features of her early rise was her comfort with intellectual risk. In academic environments, especially elite ones, there is strong pressure to align with safe research directions that promise steady progress and recognition. Pasterski showed little interest in such strategies. She gravitated instead toward unresolved problems where the likelihood of failure was high, but the potential for insight was profound. This willingness to risk uncertainty reflects a deeper confidence not in success, but in the value of inquiry itself. Another aspect of her unconventional trajectory lies in how she related to time. Many young researchers feel an urgency to achieve quickly, driven by competition and the fear of falling behind. Pasterski appeared largely indifferent to such pressures. Her work unfolded at its own pace, guided by the complexity of the questions she pursued rather than external timelines. This temporal independence is crucial for deep theoretical work, which often resists acceleration. Her approach to learning also evolved during this phase. Rather than accumulating knowledge breadth, first, she began to dig vertically into specific conceptual problems, tracing their roots across multiple areas of physics. This method allowed her to see connections that are often obscured by disciplinary boundaries. Concepts from classical mechanics, quantum theory, and general relativity began to converge within her thinking, not as separate domains, but as interrelated expressions of underlying principles. This integrative perspective is particularly evident in how she thought about symmetry. Symmetry in physics is not merely a mathematical convenience. It reflects deep constraints on how physical laws can behave. Pasterski's early fascination with symmetry was not technical alone, but philosophical. She treated symmetry as a clue, an indication that the universe may be organized by hidden structures more fundamental than the phenomena they produce. Her unconventional rise also involved a gradual distancing from the performative aspects of academia. While she remained deeply engaged with physics, she showed little interest in cultivating a public scientific persona. This choice stood in contrast to the growing visibility-driven culture of modern research, where impact is often measured by citations, presentations, and media presence. Pasterski's relative invisibility during this phase was not a lack of ambition, but a reflection of priorities. This inward focus allowed her to maintain intellectual coherence in an environment that often fragments attention. She was able to pursue long chains of reasoning without interruption, revisiting ideas repeatedly until they reached internal consistency. Such persistence is essential for foundational physics, where insights rarely arrive fully formed and often require years of refinement. Her early rise also reveals a nuanced relationship with mentorship. While she undoubtedly learned from established physicists, she did not adopt their frameworks wholesale. Instead, she treated mentorship as a dialogue rather than a directive. This allowed her to benefit from guidance without sacrificing independence. It is a delicate balance, and one that many young researchers struggle to maintain. As her thinking matured, observers began to note a distinctive clarity in how she articulated complex ideas. She did not rely on jargon to obscure uncertainty, nor did she oversimplify for the sake of accessibility. Her explanations reflected genuine understanding rather than rhetorical fluency. This clarity is often mistaken for simplicity, but it is in fact the result of deep conceptual digestion. The unconventional nature of her rise also lies in how early she began to engage with questions typically reserved for later stages of a physicist's career. While many researchers spend decades mastering tools before attempting synthesis, Pasterski showed an early inclination towards synthesis itself. She was less interested in mastering existing machinery than in understanding why that machinery took the form it did. This orientation inevitably drew comparisons to historical figures who followed similar paths. Einstein, long before developing general relativity, was preoccupied with the nature of time and simultaneity questions that lay beneath the formalism of classical physics. Pasterski's early preoccupation with spacetime structure and information echoes this pattern. In both cases, the drive to understand preceded the ability to formalize. What truly distinguishes this phase of her development is the coherence of her intellectual identity. By the time she emerged into broader scientific awareness, she was not experimenting with who she was as a thinker. That identity had already formed, quietly and independently. She was not reacting to trends or expectations. She was pursuing a line of inquiry that felt inevitable given her way of seeing the world. This inevitability does not imply ease. Her unconventional rise involved moments of isolation, misunderstanding, and resistance. Ideas that challenge foundations often encounter skepticism, especially when advanced by those early in their careers. Yet Pasterski appeared largely unfazed by such resistance. Her commitment was not to persuasion, but to truth as she understood it. As this early chapter closes, what remains most striking is how little her rise depended on conventional markers of success. There were no dramatic competitions, no viral breakthroughs, no carefully curated narrative of ascent. Instead, there was a steady accumulation of insight, guided by curiosity and sustained by intellectual integrity. This foundation explains why later comparisons to Einstein resonate so strongly, not because of fame or predictions of future greatness, but because of a shared orientation toward physics as a fundamental inquiry into reality. Both emerged not by following established paths, but by questioning why those paths existed in the first place. By the end of this formative period, Sabrina Pasterski was no longer simply a promising physicist. She was a thinker with a distinct voice, shaped by independence, depth, and a refusal to separate knowledge from meaning. Everything that followed her research, her influence, and the fascination surrounding her work can be traced back to this unconventional rise, built quietly, patiently, and from first principles. When Sabrina Pasterski arrived at Harvard, she did not enter as someone waiting to be transformed by the institution. Instead, she arrived already formed in her intellectual orientation, carrying with her a way of thinking that was both disciplined and unconventional. Harvard, with its centuries, old traditions and reputation as a center of intellectual authority, did not impose an identity upon her. Rather, it became a testing ground where her independent approach to physics was exposed to the highest levels of academic scrutiny. Harvard's physics community is known not only for technical excellence, but for its engagement with foundational questions. This environment proved uniquely compatible with Pasterski's interests, particularly her fascination with spacetime, gravity, and the deep structure of physical law. Yet compatibility did not mean conformity. From the beginning, her presence stood out because she interacted with the academic system in a way that resisted passive absorption. She treated lectures, seminars, and discussions not as endpoints of knowledge, but as invitations to interrogate assumptions. What distinguished her academic brilliance was not simply mastery of advanced material, but the way she engaged with it. Many students excel by efficiently learning existing frameworks and applying them correctly. Pasterski approached learning differently. She treated each framework as provisional, seeking to understand not only how it worked, but why it existed in its current form. This orientation transformed even routine academic exercises into opportunities for conceptual exploration. At Harvard, she immersed herself in the most abstract domains of theoretical physics, particularly those dealing with gravity and quantum theory. These fields are mathematically demanding and conceptually subtle, often requiring years of preparation before meaningful contributions can be made. Yet Pasterski showed an unusual comfort navigating this complexity. She was not intimidated by abstraction, nor did she treat it as an obstacle to intuition. Instead, she appeared to view abstraction as a language through which reality could be expressed more clearly. Her academic work demonstrated a strong sensitivity to internal consistency. She was known for questioning results that appeared correct mathematically but lacked conceptual clarity. This insistence on coherence is rare in academic environments where formal correctness is often sufficient. For Pasterski, correctness without understanding was incomplete. She sought explanations that aligned mathematical structure with physical meaning, even when such alignment was difficult to achieve. One of the most striking aspects of her academic presence at Harvard was her engagement with ideas surrounding spacetime symmetries. Symmetry plays a central role in modern physics, governing conservation laws and shaping theoretical frameworks. Pasterski's interest in symmetry was not limited to its technical applications. She treated it as a guiding principle, a window into the deeper order of the universe. This perspective allowed her to see connections between disparate areas of physics that are often treated in isolation. Her work frequently addressed questions related to information and gravity, particularly in extreme conditions such as black holes. These topics sit at the frontier of theoretical physics because they challenge the compatibility of general relativity and quantum mechanics. Rather than approaching these problems incrementally, Pasterski sought to understand their conceptual roots. She asked what it means for information to exist, how it is preserved or transformed, and what physical law implies about the nature of reality itself. In seminars and academic discussions, her contributions often took the form of reframing rather than elaboration. Instead of extending arguments along established lines, she would redirect attention to overlooked assumptions. This ability to shift perspective is a hallmark of deep understanding. It requires not only knowledge, but the confidence to question what others take for granted. Her academic brilliance also manifested in how she handled uncertainty. In theoretical physics, uncertainty is unavoidable, particularly in areas where experimental verification is limited or non-existent. Many researchers respond to this uncertainty by clinging closely to established methods. Pasterski, by contrast, appeared comfortable inhabiting conceptual ambiguity. She treated uncertainty not as a weakness, but as a signal that deeper understanding was needed. This comfort with uncertainty allowed her to engage seriously with speculative ideas while maintaining intellectual rigor. She did not dismiss unconventional approaches simply because they lay outside mainstream consensus. At the same time, she did not accept them uncritically. Her thinking maintained a balance between openness and discipline, allowing creativity to operate within logical constraints. Another defining feature of her academic life at Harvard was her relationship with productivity. In an environment where success is often measured by publications and rapid output, Pasterski's pace stood apart. She was less concerned with producing a high volume of work than with ensuring that her ideas were fully developed. This approach sometimes ran counter to institutional expectations, but it reflected a long-term commitment to depth over visibility. Her interactions with peers further highlighted her distinctive style. She was not known for dominating discussions or asserting authority. Instead, she often listened carefully, intervening only when she felt a contribution would clarify or deepen understanding. When she did speak, her remarks were typically precise and thoughtfully framed, reflecting careful consideration rather than spontaneous reaction. Harvard's academic culture provided her with access to some of the most influential physicists in the world. Yet she did not treat authority figures as arbiters of truth. She engaged with them as collaborators in inquiry, respecting expertise while maintaining her own critical stance. This attitude fostered genuine intellectual exchange rather than deference. Her academic brilliance also lay in her ability to integrate mathematical formalism with physical intuition. Many theorists excel in one domain at the expense of the other. Pasterski demonstrated an ability to move fluidly between equations and concepts, using mathematics as a tool for expression rather than an end in itself. This integration allowed her to identify patterns and structures that might otherwise remain hidden. The environment at Harvard further sharpened her interest in foundational questions. Surrounded by scholars working at the cutting edge of physics, she was exposed to competing approaches and unresolved debates. Rather than aligning herself with a particular camp, she remained focused on the underlying issues that cut across these debates. This refusal to specialize prematurely preserved the breadth of her intellectual vision. Her academic path also reflected a deliberate resistance to simplification. While popular narratives often seek clear answers and definitive conclusions, Pasterski embraced complexity. She recognized that the most important questions in physics rarely yield simple solutions. This recognition shaped her academic work, which often emphasized structure and relationship over finality. As her time at Harvard progressed, her thinking became increasingly refined. Ideas that once appeared as intuitions were subjected to rigorous examination. This process did not dilute her originality, it strengthened it. By testing her ideas against the highest standards of academic scrutiny, she ensured that creativity was matched by discipline. The significance of this phase lies not only in what she learned, but in how she learned. Harvard did not overwrite her intellectual identity, it amplified it. The institution provided tools, dialogue, and challenge, but the direction remained her own. Her brilliance emerged not from institutional molding, but from sustained engagement with questions that mattered deeply to her. This period also revealed the ethical dimension of her approach to science. She treated knowledge as a responsibility rather than a commodity. Her reluctance to rush conclusions or oversimplify ideas reflected a respect for the complexity of reality. This ethical seriousness is often overlooked in discussions of brilliance, yet it is essential for work that aims to reshape foundational understanding. By the end of this phase, Sabrina Pasterski had established herself not merely as a capable academic, but as a thinker operating at a conceptual level beyond conventional metrics. Her brilliance at Harvard was not defined by grades, titles, or accolades, but by the clarity, depth, and independence of her thought. This academic chapter did not mark a transformation so much as a confirmation. It showed that her unconventional rise was not a product of isolation, but a durable mode of thinking capable of thriving within the most demanding intellectual environments. The ideas she explored during this time would later resonate far beyond Harvard, but their roots lie in this period of intense, disciplined inquiry. And it is here, within the quiet rigor of academic life rather than the spectacle of recognition, that her reputation as an extraordinary mind truly began to take shape. As Sabrina Pasterski's academic life at Harvard progressed, the contrast between institutional expectation and individual purpose became more pronounced. While the university provided access to extraordinary intellectual resources, it also embodied a system that subtly rewards conformity, speed, and visibility. Pasterski's relationship with this system remained complex. She engaged fully with its intellectual rigor while remaining quietly resistant to its incentives. This tension did not hinder her development, rather, it sharpened it. Her work increasingly reflected a concern with the deepest unresolved questions in physics, particularly those involving gravity, spacetime, and information. These are not merely technical puzzles, but conceptual fault lines where existing theories strain under their own assumptions. Pasterski did not treat these problems as isolated challenges. She saw them as symptoms of a deeper incompleteness in our understanding of nature. This perspective allowed her to move beyond surface-level problem, solving toward structural inquiry. One of the defining features of her academic brilliance during this period was her ability to sustain long arcs of reasoning. Many theoretical projects progress in short bursts, driven by incremental results and frequent validation. Pasterski's thinking unfolded over extended periods, often revisiting the same conceptual terrain from different angles. This recursive approach allowed her to refine ideas gradually, testing their coherence across contexts rather than forcing premature conclusions. Her engagement with the physics of black holes exemplifies this mode of thought. Black holes occupy a peculiar position in modern physics, serving simultaneously as mathematical solutions, physical objects, and philosophical challenges. Questions about information, loss, event horizons, and spacetime singularities reveal deep conflicts between general relativity and quantum mechanics. Pasterski approached these issues not by attempting to resolve them immediately, but by examining the assumptions that generate them. In doing so, she paid particular attention to the role of symmetry and conservation laws. These principles have historically guided major advances in physics, often revealing hidden structures beneath complex phenomena. Pasterski treated symmetry not as an abstract constraint, but as a physical clue. She explored how subtle symmetry properties might encode information in gravitational systems, suggesting new ways of thinking about how the universe preserves order even in extreme conditions. Her academic brilliance also lay in her resistance to intellectual compartmentalization. While academic training often divides physics into specialized subfields, Pasterski consistently sought connections across boundaries. Ideas from classical mechanics, quantum field theory, and general relativity flowed together in her thinking. This integrative approach allowed her to identify conceptual patterns that remain invisible within narrower frameworks. This synthesis did not come at the expense of precision, On the contrary, her work demonstrated an acute awareness of mathematical detail. She understood that conceptual insight must ultimately be expressed through formal structure if it is to withstand scrutiny. Yet she refused to let formalism substitute for understanding. Equations, in her view, were meaningful only insofar as they illuminated physical reality. Her presence within the academic community reflected this balance. She was neither withdrawn nor performative. She participated in discussions selectively, often allowing conversations to unfold before intervening with a question or observation that reframed the issue at hand. These moments were frequently marked by a quiet clarity that shifted the direction of dialogue without assertion. As her reputation within academic circles grew, so did the expectations placed upon her. Yet she remained largely indifferent to external narratives surrounding her potential or promise. She did not cultivate a public image, nor did she actively seek recognition. This indifference was not a rejection of achievement, but a reflection of priorities. For Pasterski, understanding preceded acknowledgement. This stance sometimes placed her at odds with academic norms. The modern research environment often values continuous output and strategic positioning. Pasterski's slower, more deliberate pace challenged these norms. However, it also protected her work from becoming reactive or trend-driven. By refusing to chase fashionable problems, she preserved the integrity of her inquiry. Her brilliance during this period also manifested in how she engaged with criticism. Foundational ideas inevitably invite skepticism, particularly when they challenge established frameworks. Pasterski did not respond defensively to such skepticism. Instead, she treated it as an opportunity to refine her reasoning. Criticism became another lens through which to test coherence rather than a threat to credibility. This intellectual resilience is a crucial but often overlooked aspect of brilliance. It reflects confidence grounded not in ego, but in method. Pasterski trusted the process of inquiry itself, knowing that genuine understanding can withstand doubt and revision. This trust allowed her to remain open without becoming unfocused. Her academic life at Harvard also deepened her philosophical engagement with physics. While her work remained technically rigorous, it increasingly reflected questions about meaning and interpretation. What does it mean for spacetime to have structure? How should we understand information in a universe governed by both quantum uncertainty and relativistic causality? These questions sit at the boundary between physics and philosophy, and Pasterski navigated that boundary with unusual ease. This philosophical dimension did not distract from scientific rigor. Rather, it enhanced it. By clarifying what questions meant, she sharpened how they could be answered. This approach aligns with the tradition of physicists who viewed conceptual clarity as a prerequisite for mathematical progress. Her academic brilliance also involved an ethical dimension. She appeared deeply aware of the responsibility that comes with working on foundational theories. Simplifying complex ideas for convenience or prematurely asserting conclusions risked distorting understanding. Pasterski's caution reflected respect for the subject matter itself. She treated physics not as a domain to be conquered, but as a reality to be understood carefully. As her time at Harvard unfolded, it became increasingly clear that her brilliance could not be measured by conventional metrics alone. Grades, publications, and institutional milestones captured only a fraction of her intellectual activity. Much of her work took place internally through sustained reflection and conceptual synthesis. This invisible labor is often undervalued, yet it is precisely where transformative ideas are born. Observers began to recognize that her presence represented something rare, a thinker capable of inhabiting the most abstract regions of physics without losing contact with meaning. She did not treat complexity as a badge of expertise, but as a challenge to be clarified. This orientation distinguished her from peers who equated difficulty with depth. By the conclusion of this academic phase, Pasterski had not merely advanced within the system, she had tested its limits. She demonstrated that it was possible to engage deeply with elite academic environments without being defined by them. Her brilliance lay in preserving intellectual autonomy while operating at the highest level of rigor. This period also set the stage for the broader attention that would later surround her work. The foundations she laid at Harvard were not immediately visible to the public, but they were unmistakable to those attuned to conceptual depth. Her ideas resonated because they addressed problems that many physicists sensed but struggled to articulate. In retrospect, this phase reveals that her academic brilliance was not an achievement layered onto her identity, but an expression of it. Harvard did not create her way of thinking. It revealed it under pressure. The clarity, independence, and depth she displayed were not products of institutional refinement, but qualities she carried with her into that environment. As this chapter closes, what remains is a portrait of a physicist whose brilliance was defined not by accumulation, but by alignment. Her ideas, methods, and values converged into a coherent intellectual stance, one capable of confronting the deepest questions in physics without surrendering to either dogma or spectacle. It is from this quietly rigorous academic foundation that her later work would emerge, drawing attention not because it sought the spotlight, but because it illuminated places where understanding had long remained incomplete. As Sabrina Pasterski moved beyond the formative stages of academic training, her work began to take on a distinctly transformative character. This phase marked the point at which her thinking no longer revolved solely around learning existing theories or interrogating their assumptions, but around contributing new structures of understanding to theoretical physics itself. The transition was subtle rather than dramatic, unfolding through sustained engagement with problems that lie at the deepest boundaries of modern science. The areas she chose to focus on were among the most conceptually demanding in physics. Questions involving gravity, spacetime, and quantum information occupy a unique position because they resist unification under any single theoretical framework. General relativity describes gravity as the geometry of spacetime, while quantum mechanics governs the behavior of particles and fields at microscopic scales. Reconciling these perspectives remains one of the greatest unresolved challenges in science. Pasterski's work entered precisely at this fault line. Rather than attempting to force a direct unification, she approached the problem from an unexpected direction. Her interest centered on the role of symmetry and structure in physical law. Symmetry has long been a guiding principle in physics, revealing conservation laws and underlying order. Pasterski explored how symmetries operate not just in simple systems, but in extreme gravitational environments where spacetime itself becomes dynamic. One of her most influential lines of work involved the study of asymptotic symmetries, subtle symmetries that arise at the boundaries of spacetime rather than within its interior. These symmetries had been known for decades, but were often treated as mathematical curiosities with limited physical significance. Pasterski helped demonstrate that they play a far more profound role, particularly in how information is encoded and preserved in gravitational systems. Her work suggested that information about physical processes may be stored not locally, but globally, in the structure of spacetime itself. This idea has deep implications for long-standing puzzles such as the black hole information paradox, which questions whether information that falls into a black hole is lost forever. By examining how symmetries constrain physical behavior at spacetime boundaries, Pasterski provided new ways of thinking about how information could be conserved even in the presence of extreme gravitational collapse. What made this work groundbreaking was not only its technical sophistication, but its conceptual reframing of the problem. Instead of treating black holes as isolated objects that destroy information, she approached them as participants in a larger spacetime structure governed by symmetry. This shift in perspective opened new avenues for resolving paradoxes that had resisted decades of analysis. Her contributions also bridged areas of physics that had traditionally developed in parallel. By connecting gravitational physics with ideas from quantum field theory and information theory, she demonstrated that insights often emerge at intersections rather than within silos. This integrative approach reflected her broader intellectual philosophy, that understanding deepens when boundaries are questioned. Another aspect of her breakthrough work involved gravitational scattering, the study of how particles and waves interact through gravity at high energies. While scattering is a standard tool in particle physics, applying it to gravitational contexts introduces immense complexity. Pasterski explored how symmetry principles govern these interactions, revealing patterns that suggest an underlying simplicity beneath apparent chaos. These investigations revealed that certain features of gravitational interactions remain universal, independent of specific details. Such universality is a hallmark of fundamental principles in physics. By identifying it in gravitational systems, Pasterski's work hinted at deeper organizing laws that could guide future theoretical development. Her approach to mathematics during this period was notable for its restraint. She employed advanced mathematical tools when necessary, but she resisted allowing formalism to obscure meaning. Each calculation served a conceptual purpose, reinforcing her insistence that mathematics should clarify rather than dominate physical understanding. This discipline distinguished her work in a field where complexity often escalates unchecked. The reception of her work within the theoretical physics community reflected its significance. Her ideas attracted attention not because they promised immediate solutions, but because they reframed long-standing problems in a way that felt both original and inevitable. Other researchers began exploring extensions and implications of her insights, integrating them into broader research programs. What is particularly striking is that these breakthroughs did not emerge from a single dramatic publication, but from a coherent body of thought developed over time. Pasterski's work exemplified how scientific progress often occurs not through isolated moments of inspiration, but through sustained clarity of vision. Her thinking during this phase also displayed an unusual sensitivity to physical interpretation. She was acutely aware that theoretical physics risks becoming detached from empirical meaning when abstraction is pursued without restraint. Her work consistently returned to questions about what physical reality is doing, not just what equations allow. This grounding in interpretation allowed her to engage productively with debates that often become polarized. For example, discussions about whether spacetime is fundamental or emergent frequently devolve into competing metaphysical claims. Pasterski approached such debates pragmatically, focusing on which assumptions yielded coherent explanations and which introduced contradictions. Another hallmark of her breakthrough work was its minimalism. She sought the simplest structures capable of explaining complex phenomena. This aesthetic preference aligns with a long tradition in physics, where elegance often signals truth. Yet her minimalism was not stylistic. it was methodological. By stripping problems down to their essentials, she exposed hidden relationships that complexity had concealed. Her work also carried implications beyond black holes and gravity. By emphasizing the role of symmetry and information, it contributed to a broader shift in physics toward viewing information as a fundamental physical quantity. This perspective has gained increasing prominence, influencing fields ranging from quantum computing to cosmology. Despite the depth of her contributions, Pasterski remained cautious about overextension. She resisted grand claims unsupported by rigorous reasoning. This restraint enhanced the credibility of her work, ensuring that speculation remained tethered to logic. It also reflected her respect for the provisional nature of scientific knowledge. During this period, her reputation grew quietly but steadily. She was recognized among peers as someone capable of identifying where existing theories strain against their limits. This ability to sense structural tension is a rare form of insight. It allows a physicist to focus effort where it matters most. Her breakthrough work also revealed a deep continuity with her earlier intellectual development. The same independence, insistence on understanding, and resistance to superficial success that characterized her early rise now manifested at a higher level of abstraction. Her ideas did not represent a departure from her past, but its natural extension. As this phase unfolded, it became increasingly difficult to categorize her work within traditional boundaries. It was neither purely mathematical nor purely conceptual, neither strictly gravitational nor strictly quantum. This hybridity made her work challenging to classify, but also uniquely valuable. By the end of this stage, Sabrina Pasterski had established herself as a contributor to the foundational discourse of theoretical physics. Her work did not offer final answers, but it reshaped the questions themselves. In doing so, it exemplified the deepest function of theoretical inquiry, not to close debates, but to open them in more productive directions. This first half of her breakthrough story reveals how originality emerges when clarity, patience, and conceptual courage converge. The full implications of her work would continue to unfold, influencing how physicists think about spacetime and information in the years to come. As Sabrina Pasterski's ideas began to circulate more widely within theoretical physics, their significance became increasingly apparent not through publicity, but through resonance. Other researchers did not merely cite her work, they engaged with it, tested it, and extended it. This is often the clearest signal of a genuine breakthrough. When ideas alter the way problems are framed, they begin to live independently of their originator. One of the most profound consequences of her work was how it reframed the relationship between gravity and information. For decades, physicists had struggled with the paradoxes arising from black holes, particularly the question of whether information is destroyed when matter falls beyond an event horizon. Traditional approaches tended to focus on what happens inside the black hole, where known laws break down. Pasterski's work redirected attention outward, toward the structure of spacetime itself and the symmetries that govern it. This shift may appear subtle, but its implications are vast. By emphasizing boundary structures and global symmetries, her work suggested that information need not be localized in the way classical intuition demands. Instead, it may be encoded in relational structures that persist even when local descriptions fail. This perspective aligns with emerging ideas in quantum gravity, yet Pasterski's contribution lay in grounding these ideas within rigorous symmetry principles rather than speculative metaphysics. Her approach also brought new clarity to gravitational scattering processes. In high-energy regimes where gravity becomes dominant, calculations often grow unwieldy and opaque. Pasterski identified patterns within this complexity that hinted at underlying simplicity. These patterns suggested that gravitational interactions, despite their apparent intricacy, may obey organizing principles similar to those found in other fundamental forces. This insight challenged a long-standing assumption that gravity is inherently resistant to the kinds of simplifications that work elsewhere in physics. By revealing structural order where chaos was expected, her work encouraged a re-examination of how gravity is treated within quantum frameworks. It suggested that the obstacle to unification may lie less in gravity itself and more in the conceptual tools traditionally applied to it. Another lasting impact of her break-through phase was its influence on how physicists think about spacetime. Rather than treating spacetime as a passive stage on which physical processes unfold, her work emphasized its active role in organizing information. Spacetime, in this view, is not merely geometry, but a participant in physical law. This conception resonates with Einstein's insight that gravity is geometry, yet it extends that idea into the quantum domain. What makes this extension particularly compelling is its restraint. Pasterski did not claim to have resolved the tension between quantum mechanics and general relativity. Instead, she clarified where that tension arises and why certain assumptions may be obstructing progress. This diagnostic approach is often more valuable than premature synthesis. By identifying structural incompatibilities, she helped narrow the search for resolution. Her work also influenced the language physicists use to describe foundational problems. Terms like symmetry, boundary, and information took on richer meanings, no longer confined to technical contexts, but integrated into broader conceptual narratives. This linguistic shift matters because language shapes thought. When physicists speak differently about problems, they often begin to think differently as well. As her ideas gained traction, they began to intersect with parallel developments in theoretical physics. Research in holography, quantum information, and emergent spacetime found points of contact with her work. These intersections did not dilute her contributions, they amplified them. Her ideas acted as connective tissue, linking efforts that had previously seemed disconnected. Despite this growing influence, Pasterski remained notably reserved in her claims. She did not present her work as revolutionary, nor did she frame it as a challenge to existing authorities. This restraint enhanced its credibility. In a field where bold declarations often outpace evidence, her careful articulation stood out as a mark of seriousness. Her breakthrough phase also demonstrated a rare ability to remain intellectually flexible. As others engaged with and sometimes critiqued her ideas, she did not cling to them defensively. Instead, she treated critique as part of the evolutionary process of understanding. This openness allowed her work to adapt and mature rather than ossify. Another important dimension of this period was the way her work influenced younger researchers. Graduate students and earlier career physicists found in her approach a model for how to engage with foundational problems without sacrificing rigor. She showed that it was possible to ask large questions responsibly, without resorting to vagueness or speculation. This influence is difficult to quantify, but it is deeply significant. La PH, YSICPSOS, ICIDEPE, O acute NDN que, not only on specific NING, U acute HOMBRE, USA results, but on modes of thinking that encourage depth, patience, and clarity. Pasterski's work exemplified these qualities, offering an alternative to both narrow technicalism and unfounded grandiosity. Her ideas also reignited interest in questions that had been set aside as intractable. By reframing these questions, she made them approachable again, not in the sense of easy answers, but in the sense of renewed conceptual traction. Problems once seen as dead ends began to appear as gateways to deeper structure. Throughout this phase, a striking continuity remained evident between her technical work and her philosophical orientation. She consistently treated physics as a search for meaning as well as mechanism. This did not blur the boundary between science and philosophy, it clarified it. Philosophy, in her work, functioned as a guide to interpretation rather than substitute for calculation. This integration of philosophy and physics is often associated with earlier eras of science, yet Pasterski demonstrated its ongoing relevance. In confronting questions about spacetime and information, philosophical clarity becomes indispensable. Her work showed that ignoring conceptual foundations does not eliminate philosophical assumptions. It merely leaves them unexamined. As her breakthrough contributions accumulated, comparisons to historical figures grew more frequent. Yet what truly set her apart was not resemblance to any single predecessor, but her embodiment of a mode of inquiry that transcends eras. She worked at the level where physics renews itself, where questions are reformulated rather than merely answered. By the end of this phase, it was clear that her work had altered the landscape of theoretical discussion. Even those who disagreed with her conclusions found themselves responding to her framing. This is perhaps the clearest mark of impact. When ideas become unavoidable, they have already succeeded. Her breakthroughs did not resolve the deepest mysteries of physics, nor did they claim to. Their significance lies instead in how they reshaped the intellectual terrain. They clarified what is at stake, what assumptions matter, and where genuine progress might emerge. This phase of her work also reinforced the sense that her intellectual trajectory was guided by coherence rather than ambition. She did not chase recognition. Recognition followed engagement. Her influence grew not because she sought attention, but because her ideas illuminated dark corners of understanding. As this chapter closes, Sabrina Pasterski emerges not merely as a contributor to theoretical physics, but as a shaper of its conceptual direction. Her breakthroughs did not announce a final theory, but they sharpened the tools with which such a theory might one day be built. In this way, her work fulfilled one of the highest functions of science, not to provide closure, but to deepen inquiry. It reminded the physics community that progress often begins not with answers, but with better questions, and with the courage to ask them where certainty ends. At a certain point in Sabrina Pasterski's trajectory, the comparison to Albert Einstein began to surface with increasing frequency. This comparison did not originate from marketing campaigns or self-promotion, nor did it arise from any single discovery that mirrored a specific achievement of Einstein's. Instead, it emerged gradually, almost reluctantly, from a recognition among physicists and observers that her way of thinking bore a striking resemblance to the mode of inquiry that has historically preceded major revolutions in physics. To understand why such a comparison gained traction, it is essential to move beyond superficial parallels and examine the underlying qualities that define scientific transformation. Einstein is remembered not merely for his equations, but for his willingness to question the most basic assumptions about space, time, and reality. His genius lay in identifying where accepted ideas had quietly hardened into dogma. Pasterski's work resonated in a similar way, not because it replicated Einstein's conclusions, but because it exhibited the same instinct to interrogate foundations rather than extend structures. Uncritically, one of the earliest reasons the comparison arose was her relationship with established theory. Pasterski did not treat existing frameworks as monuments to be preserved, nor as obstacles to be demolished. She treated them as provisional maps, useful representations of reality that nevertheless remain incomplete. This stance mirrors Einstein's early dissatisfaction with Newtonian mechanics and classical electrodynamics. In both cases, the discomfort was not with results, but with coherence. Certain ideas worked extraordinarily well, yet sat uneasily beside others. This tension became a signal rather than a nuisance. Observers noticed that Pasterski consistently gravitated toward these points of tension. She was less interested in refining what already worked and more interested in understanding why it worked at all. This orientation distinguishes foundational thinkers from technical specialists. It requires a willingness to suspend certainty and to tolerate ambiguity, traits that are psychologically demanding in a discipline that prizes precision. Another reason the comparison to Einstein gained momentum lies in her conceptual imagination. Pasterski demonstrated an ability to think in terms of structures rather than objects. Where many physicists focus on particles, fields, or forces, she focused on relationships, symmetries, and constraints. This shift in perspective echoes Einstein's transition from forces to geometry in his understanding of gravity. By reframing problems in terms of structure, both thinkers opened conceptual space for new laws to emerge. Her work repeatedly emphasized that what appears complex at the surface may be governed by simple organizing principles beneath. This belief is not merely aesthetic, it is methodological. It reflects confidence that nature is intelligible at a deep level, even when current theories fall short. Einstein famously held that the universe is comprehensible, and this conviction guided his search for unified explanations. Pasterski's work reflects a similar faith in underlying order, even in domains where fragmentation has long prevailed. The comparison was further reinforced by her attitude toward authority. Pasterski showed respect for the achievements of past physicists, but she did not treat reputation as a substitute for reasoning. Ideas earned legitimacy in her thinking only when they satisfied internal coherence and explanatory power. This epistemic independence is rare and often misunderstood. It can appear dismissive or contrarian when, in fact, it reflects a deep sense of responsibility toward truth. Einstein exhibited this same independence early in his career, questioning accepted interpretations even when doing so isolated him professionally. Pasterski's willingness to remain intellectually solitary when necessary evoked similar patterns. She did not seek validation through alignment. She sought understanding through scrutiny. This trait alone accounts for much of the resonance between her work and Einstein's legacy. Another dimension of the comparison involves her treatment of time and spacetime. While Einstein revolutionized physics by reconceptualizing time as relative and intertwined with space, Pasterski's work explored how spacetime itself encodes information and structure. Though operating within a vastly different theoretical landscape, she demonstrated a similar sensitivity to the deep role spacetime plays in organizing physical law. Time, in her work, is not merely a parameter, but a feature whose meaning depends on symmetry and boundary conditions. This sensitivity reflects a deeper philosophical alignment. Both thinkers approached physics as a way of understanding reality itself, not merely predicting outcomes. For them, equations were not ends in themselves, but expressions of deeper truths. This orientation often leads to slower progress by conventional standards, but it also opens the possibility of transformative insight. The label of Next Einstein also emerged in response to Pasterski's refusal to fragment her thinking. Modern physics often divides problems into manageable pieces, each addressed with specialized tools. Pasterski resisted this fragmentation, preferring to trace connections across domains. She saw gravity, quantum mechanics, and information not as separate topics, but as interwoven aspects of a single conceptual challenge. This holistic approach echoes Einstein's lifelong pursuit of unification. Importantly, the comparison did not suggest that Pasterski was attempting to replicate Einstein's path or achievements. Rather, it reflected recognition that her intellectual posture aligned with a rare historical pattern. Transformative thinkers tend to share certain traits regardless of era: discomfort with unresolved contradictions, resistance to premature closure, and a commitment to conceptual clarity over technical accumulation. Pasterski exhibited these traits consistently. Public fascination with the comparison often obscured its subtler meaning. Media narratives tend to reduce such labels to predictions of fame or singular genius. In reality, the comparison functioned more as a diagnostic than a prophecy. It indicated that her way of engaging with physics operated at a level where paradigms are questioned rather than optimized. Her personal demeanor also contributed to the perception. Like Einstein, Pasterski appeared largely indifferent to external markers of success. She did not cultivate celebrity, nor did she present herself as a visionary figure. This modesty reinforced the sense that her work was driven by intrinsic motivation rather than ambition. Such motivation is often a prerequisite for sustained engagement with foundational problems, which offer little immediate reward. Another factor in the comparison was her clarity of expression. When Pasterski explained complex ideas, she did so with a precision that revealed deep understanding rather than rehearsed fluency. This clarity is often associated with Einstein, who famously emphasized that if one cannot explain an idea simply, one does not understand it fully. Pasterski's explanations reflected the same principle, not as a stylistic choice, but as a natural outcome of coherent thinking. The comparison also arose because her ideas, like Einstein's, prompted others to rethink assumptions they had long accepted. Even physicists who disagreed with her conclusions found their own thinking sharpened by engaging with her framing. This effect is rare and significant. It suggests that an idea has reached a level of depth where it reshapes the intellectual environment rather than merely contributing to it. At the same time, Pasterski herself remained cautious about such comparisons. She did not embrace the label, nor did she encourage its use. This restraint reflects an awareness of the burden such narratives impose. Einstein's legacy is singular and historically situated. Pasterski's work unfolds in a different context, shaped by contemporary challenges and tools. Any meaningful comparison must therefore operate at the level of method and mindset rather than outcome. The persistence of the comparison, nonetheless, reveals something important about how scientific communities recognize potential transformation. Long before revolutions are complete, they are sensed through patterns of thought. Pasterski's work signaled such patterns not through dramatic claims, but through quiet consistency. Her focus on structure, symmetry, and meaning echoed the intellectual instincts that once led Einstein to question absolute space and time. As this phase of her story unfolds, it becomes clear that being called the next Einstein is less about individual destiny than about collective recognition. It reflects a shared intuition that her approach addresses the kinds of questions that precede major shifts in understanding. Whether or not such shifts ultimately occur is a matter for history to decide. What matters is that her work occupies the conceptual terrain where such shifts become possible. This first half of the explanation shows that the comparison emerged not from exaggeration, but from resonance. It arose because her way of thinking aligned with a tradition of inquiry that has, at rare moments, redefined physics itself. The label persists not because it promises certainty, but because it captures a sense of intellectual possibility that is difficult to articulate otherwise. As the comparison between Sabrina Pasterski and Albert Einstein continued to circulate, it began to take on a life of its own, extending beyond academic circles into broader public discourse. This expansion brought both attention and distortion. On one hand, it introduced her work to audiences who might otherwise never engage with theoretical physics. On the other, it risked simplifying a complex intellectual trajectory into a familiar narrative of singular genius. Understanding the real significance of the comparison requires disentangling these effects. Public fascination with the idea of a next Einstein reflects a deep cultural longing for clarity in an age of complexity. Einstein symbolizes a moment when the universe seemed to yield its secrets to human reason through a single coherent vision. In contrast, modern physics often appears fragmented, technical, and inaccessible. Pasterski's work, with its emphasis on foundational structure and conceptual coherence, resonated with the hope that such unity might once again be possible. Yet, within the scientific community, the comparison carried a more restrained meaning. Physicists recognized that the conditions which produced Einstein's breakthroughs were historically unique. Pasterski operates in a vastly different intellectual landscape, one defined by advanced mathematics, collaborative research, and unresolved theoretical tension rather than experimental crisis. The comparison, therefore, did not imply repetition, but analogy at the level of intellectual posture. This distinction is crucial. Einstein's revolutions emerged from contradictions between classical mechanics and electromagnetism that demanded resolution. Today's contradictions, particularly between quantum mechanics and gravity, are subtler and less accessible to direct experimentation. Pasterski's work engages precisely with these subtleties, suggesting that progress now depends less on dramatic reconceptualization and more on uncovering hidden structural principles. The comparison to Einstein, thus, reflects a shared engagement with foundational tension, not identical historical circumstances. The label also influenced expectations placed upon her. Comparisons of this magnitude inevitably carry implicit predictions of transformative discovery. Such expectations can be burdensome, particularly in theoretical physics, where progress is often slow and uncertain. Pasterski's response to this pressure was notable for its composure. She neither rejected the comparison aggressively nor embraced it as a mantle. Instead, she continued her work with the same measured focus that had defined her career thus far. This response further reinforced the comparison. Einstein himself famously resisted hero worship, emphasizing the collective nature of scientific progress. Pasterski's reluctance to adopt a prophetic role mirrored this attitude. She appeared aware that genuine understanding cannot be accelerated by narrative, nor can it be compelled by expectation. Another layer of meaning behind the comparison lies in how it challenged prevailing definitions of genius. Modern culture often equates brilliance with speed, productivity, or spectacle. Pasterski's work subverted these associations. Her influence grew not through rapid accumulation of results, but through depth, patience, and conceptual coherence. This model of genius aligns more closely with Einstein's legacy than with contemporary stereotypes. The comparison also sparked renewed discussion about the role of intuition in physics. Einstein famously relied on thought experiments and conceptual reasoning to guide his discoveries. Pasterski's work, though mathematically rigorous, similarly emphasized intuition about structure and symmetry. She demonstrated that even in an era of extreme abstraction, intuition remains indispensable. This emphasis resonated with physicists who sensed that technical mastery alone is insufficient for foundational progress. At the same time, the comparison revealed discomfort within the scientific community. Labels like "Next Einstein" risk oversimplifying collaborative and incremental processes. Pasterski's work, while distinctive, exists within a broader ecosystem of ideas. The comparison therefore served as a reminder of how narratives can obscure collective effort even as they highlight individual contribution. Importantly, Pasterski herself did not position her work as revolutionary in the grand sense. She consistently framed her contributions as steps toward understanding rather than final answers. This humility contrasts sharply with the absolutism often projected onto Einstein's achievements in retrospect. It also reflects a modern awareness of the provisional nature of scientific knowledge. The persistence of the comparison, nonetheless, suggests that something genuine is being recognized. It indicates that her work touches questions that lie beneath technical disagreement, questions about how reality is structured and how knowledge is possible. These are the same kinds of questions that once motivated Einstein to reconsider space and time. The similarity lies not in solution, but in orientation. The comparison also reshaped how young scientists perceive their own paths. Pasterski's example challenged the notion that success requires constant visibility or adherence to fashionable problems. She showed that it is possible to pursue deep questions quietly and still exert significant influence. This lesson, though less dramatic than revolutionary discovery, may ultimately prove more transformative for the culture of physics. In a broader sense, the label of "Next Einstein" functioned as a cultural mirror. It reflected society's desire for meaning, coherence, and intellectual courage in a world increasingly shaped by complexity and specialization. Pasterski's work became a symbol of these values, even as she herself remained focused on the substance rather than the symbolism. As time passed, the comparison matured. It shifted from a headline-driven claim to a more thoughtful recognition of intellectual lineage. Pasterski was no longer framed as a future savior of physics, but as a participant in a long tradition of thinkers who engage with nature at its deepest level. This reframing allowed the comparison to retain meaning without becoming burdened by unrealistic expectation. Ultimately, the significance of being called the next Einstein lies not in prediction, but in perspective. It highlights a mode of inquiry that prioritizes understanding over accumulation, coherence over convenience, and meaning over momentum. Pasterski's work exemplifies this mode not by imitation, but by necessity. The problems she addresses demand it. As this chapter closes, the comparison stands revealed not as a claim about destiny, but as an observation about method. It acknowledges that her way of thinking occupies the rare intellectual space where physics confronts its own foundations. Whether or not history ultimately associates her name with a singular revolution, her work already fulfills a quieter but equally vital role, keeping the deepest questions alive and intelligible. In that sense, the comparison to Einstein is less about her future than about our present. It reminds us that physics advances not only through data and computation, but through minds willing to ask why the universe is the way it is, even when answers remain uncertain. And it is precisely this willingness that gives the comparison its enduring resonance. As Sabrina Pasterski's work matured, it became increasingly evident that her influence extended far beyond the individual level of insight and into the broader dynamics of the scientific community. At this stage, her role was not simply that of a solitary researcher producing elegant ideas in isolation. Rather, she began to shape the ways in which other physicists approached the deepest questions in their field. Her thinking introduced subtle yet profound shifts in perspective, revealing that influence in theoretical physics does not always come from grand declarations or headline discoveries, but often from the ability to reframe what questions are considered meaningful and how they might be approached. Central to this influence was the way Pasterski approached collaboration and intellectual exchange. Unlike many highly productive theorists who operate almost exclusively within tight-knit groups, she engaged with a broad network of peers while maintaining her own conceptual independence. Her contributions to seminars, conferences, and informal discussions often took the form of clarifying conceptual structure rather than offering direct technical solutions. This approach encouraged others to examine foundational assumptions in their own work, leading to a ripple effect in which the quality of discourse across multiple research groups improved. Her presence in these collaborative spaces demonstrated that intellectual leadership in physics does not require dominance or assertiveness. Pasterski's style was notable for its subtlety. She would pose a question or point out an overlooked symmetry, and this would often redirect an entire discussion, prompting colleagues to reconsider problems from a fresh angle. By doing so, she reinforced a culture in which questioning foundational assumptions was not just permitted, but expected. In a field where earlier researchers often hesitate to challenge established frameworks, her example proved transformative. During this period, her work also increasingly intersected with the growing dialogue between gravitational physics and quantum information theory. Historically, these domains evolved largely in parallel, with their interactions largely limited to speculative thought experiments. Pasterski's research highlighted the deep connections between the two, demonstrating that understanding the role of symmetry in gravitational systems could illuminate questions about information, preservation, entanglement, and even the emergent nature of spacetime itself. This synthesis was subtle but powerful, creating new research pathways that many groups have since pursued. Her influence was particularly pronounced in the study of gravitational scattering and asymptotic symmetries. While these topics had been studied independently by various researchers, Pasterski's contributions unified them under a conceptual framework emphasizing the role of boundary conditions and global constraints. She showed that seemingly technical details, such as the precise behavior of fields at infinity, could carry profound implications for information theory and the unification of physics. By reframing what aspects of these systems were physically significant, she reshaped the priorities and focus of ongoing research in a way that extended well beyond her own publications. Pasterski's intellectual rigor was complemented by a remarkable clarity of reasoning. In an environment where highly complex mathematics can obscure physical meaning, she demonstrated a consistent ability to distill intricate formalism into conceptual insight. This clarity proved invaluable to colleagues and collaborators, many of whom credited her interventions with making seemingly intractable problems more approachable. In this sense, her influence functioned less as a directive and more as a structural guide. she illuminated the conceptual terrain, enabling others to navigate it with greater precision. This period of her career also revealed her impact on the culture of mentorship and intellectual development in high-level physics. While she did not hold formal teaching positions at this stage, her engagement with peers often carried a pedagogical dimension. By modeling patience, careful reasoning, and attention to foundational clarity, she created a kind of informal apprenticeship environment. Younger researchers, observing how she approached conceptual puzzles, absorbed a set of methodological habits that emphasized depth over speed and understanding over mere technical prowess. In a field increasingly pressured by the pace of publication, this emphasis on quality over quantity was significant. Another dimension of her influence involved her engagement with problems that straddle multiple subfields. Pasterski consistently resisted the tendency to silo knowledge, instead seeking connections across gravitational physics, quantum field theory, and even emergent approaches to cosmology. By demonstrating that insights often arise at these intersections, she inspired other researchers to adopt a more integrative approach. This perspective contrasts sharply with conventional expectations in modern physics, where hyper-specialization is often necessary for technical mastery, but can inadvertently limit conceptual breadth. Her ability to identify deep conceptual links also made her a sought-after interlocutor in collaborative projects. When physicists encountered problems that seemed resistant to standard techniques, they increasingly consulted her not only for technical insight, but for structural reasoning. This role reflects a rare kind of influence, the capacity to shape research trajectories through framing, rather than through incremental technical results alone. It is a form of intellectual leadership that operates quietly but profoundly, guiding others toward productive avenues of inquiry. At the same time, her work began to be recognized for its implications outside purely theoretical domains. The principles she elucidated regarding symmetry, boundary conditions, and information conservation resonated with researchers in quantum computing, holography, and even high-energy phenomenology. While these fields are distinct, they share underlying questions about the nature of information, structure, and interaction. Pasterski's contributions provided conceptual tools that could be adapted across these domains, demonstrating that foundational theoretical insight has broad applicability when it is well framed and precisely articulated. Her influence also extended to shaping how physicists think about the relationship between mathematics and physical meaning. In her work, formalism is always tethered to conceptual clarity. Equations are not treated as ends in themselves, but as expressions of structural principles. This stance contrasts with the tendency in some corners of modern physics to valorize technical sophistication over interpretive insight. By modeling the integration of formal rigor with intuitive understanding, she encouraged a culture in which mathematical mastery serves comprehension rather than obscuring it. Pasterski's work during this period further exemplified a distinctive approach to the pace and scope of research. In a professional culture increasingly driven by rapid output and citation metrics, she maintained a deliberate rhythm. Her projects developed through careful thought, recursive refinement, and repeated conceptual testing. This patience was not a weakness, but a strategic advantage. It allowed her insights to mature fully before being deployed in the broader community. The resulting influence was durable rather than fleeting, reinforcing her reputation as a thinker whose contributions carry long-term significance. Another notable feature of her engagement with the scientific community was her insistence on the importance of unanswered questions. Pasterski demonstrated that the value of research often lies not in immediate solutions, but in illuminating where understanding remains incomplete. By framing problems in ways that highlight structural tension and conceptual ambiguity, she guided colleagues to prioritize questions that could yield meaningful breakthroughs over those that offered only incremental progress. This focus on the right problems, rather than simply solvable problems, became a hallmark of her influence. Her work also reinforced the importance of intellectual humility in scientific discourse. Despite her growing recognition and the weight of expectation surrounding her contributions, she remained open to critique and alternative interpretations. This receptivity allowed her ideas to evolve collaboratively, strengthening their conceptual foundation. It also modeled a form of professionalism in which authority derives from the robustness of reasoning rather than the status of the individual. The cumulative effect of these practices was a subtle transformation in the culture of high-level theoretical physics. Pasterski's presence encouraged a more reflective and integrative approach to foundational problems, emphasizing clarity, connection, and patience. Her influence operated less as a set of prescriptions than as a shift in how researchers perceived the structure of the questions they were tackling. Her work's visibility within the global physics community further amplified this effect. Presentations at international conferences, participation in collaborative seminars, and informal exchanges with researchers around the world allowed her conceptual framework to propagate beyond her immediate collaborators. Unlike celebrity-driven influence, this propagation was structural. It changed how problems were framed, how symmetries were considered, and how information theory intersected with gravitational physics. By the end of this period, it became clear that Pasterski had established a distinctive intellectual role, that of a boundary, pushing researcher whose impact was measured less by immediate results and more by how she reshaped thinking across multiple domains. She demonstrated that influence in modern theoretical physics can be exercised through conceptual framing, methodological rigor, and integrative vision as much as through technical breakthroughs or experimental confirmation. Her trajectory at this stage underscores a crucial lesson about scientific impact. Transformative influence is not always the product of singular achievements. It can arise from consistent modeling of intellectual virtues, independence, clarity, patience, and the ability to connect ideas across domains. In this sense, Pasterski's work exemplifies a rare form of leadership in the scientific community, one that subtly but permanently alters the contours of research even without dramatic public attention. Through this period of global engagement, her work continued to inspire questions that many physicists had long considered intractable. By reframing problems in terms of symmetry, boundary structure, and information conservation, she created new pathways for investigation. Her influence demonstrated that foundational research thrives when it is guided by clarity of vision rather than adherence to established methods, and that the intellectual ecosystem itself can be shaped by the example of a single, deeply thoughtful mind. As her ideas circulated more widely, the depth of Pasterski's influence became increasingly evident in how they were applied to emerging theoretical frameworks. Researchers working on quantum gravity, holography, and black hole information problems began to integrate her insights into their own models. This integration was not superficial. Her work provided conceptual scaffolding that enabled more coherent connections between previously disparate areas of inquiry. By showing that the behavior of gravitational systems could be systematically understood in terms of symmetry and information conservation, she offered tools that could be adapted across multiple subfields, accelerating the development of integrative approaches in theoretical physics. Her impact was not limited to the mechanics of specific calculations. By emphasizing the structural importance of boundary conditions and asymptotic symmetries, she changed how physicists conceptualize physical systems at the most fundamental level. These concepts, once viewed as technical curiosities, began to be seen as central to understanding how information persists and transforms in extreme environments. This conceptual shift influenced not only research strategies, but also how theoretical models were interpreted, moving the community toward a more unified understanding of gravity and quantum phenomena. Pasterski's work also catalyzed more collaborative and interdisciplinary approaches. Physicists studying high-energy particle interactions, black hole thermodynamics, and quantum information theory found common ground in her frameworks. This led to collaborations that might have seemed unlikely prior to her contributions, as her ideas provided a shared conceptual language across fields that traditionally operated in isolation. By facilitating dialogue between these domains, she helped break down silos that had long limited the scope of theoretical exploration. Her role in these collaborations was distinctive. She rarely positioned herself as the dominant voice. Instead, she functioned as a conceptual integrator. Her contributions often took the form of reframing problems, clarifying assumptions, and highlighting connections that others had overlooked. In doing so, she encouraged a culture of collective reasoning where the quality of questions mattered as much as the precision of calculations. This approach not only produced immediate insights, but also strengthened the intellectual resilience of the groups she engaged with. At the same time, her influence extended to methodological innovation. By demonstrating how symmetry principles could guide reasoning about gravitational interactions and information flow, she encouraged researchers to adopt more principled approaches to modeling. Instead of relying solely on computational brute force or heuristic approximations, her work illustrated the power of grounding inquiry in conceptual clarity. This methodological shift, though subtle, has lasting implications for how high-level theoretical physics is practiced. Another important aspect of her influence during this period was the way it reshaped expectations around foundational research. Pasterski's success highlighted that transformative contributions do not always emerge from rapid, high-volume output. Instead, they often arise from sustained, reflective engagement with complex problems. Her example encouraged peers and junior researchers alike to value patience, deep understanding, and the careful cultivation of ideas over immediate productivity. In a culture often dominated by metrics, this emphasis on intellectual integrity had a profound cultural effect. Her work also contributed to refining the questions themselves. By framing black hole behavior, gravitational scattering, and spacetime structure in terms of symmetry and information, she highlighted inconsistencies and gaps in existing models. This reframing did more than point out limitations. It illuminated new paths for inquiry. Researchers could now identify the precise points where current understanding was incomplete, guiding experimental and theoretical efforts more effectively than ever before. In this sense, her contributions functioned as both lens and compass, clarifying the terrain and suggesting the direction for exploration. Internationally, her influence grew as her ideas were discussed and applied across different research institutions and collaborations. Workshops, conferences, and collaborative papers began to reflect her conceptual frameworks. Her ability to communicate complex, abstract ideas with clarity made her a natural interlocutor in these contexts, facilitating productive dialogue between groups with varying expertise and perspectives. This effect was particularly pronounced in projects involving high-energy physics and quantum gravity, where the integration of diverse approaches is crucial. In addition, her work helped bridge the gap between theoretical abstraction and conceptual intuition. While her insights were grounded in rigorous mathematics, she consistently emphasized their physical interpretation. This dual focus allowed her to influence both specialists deeply familiar with technical formalisms and broader communities seeking to understand the implications of modern physics. By maintaining this balance, she reinforced a model of influence in which conceptual clarity and technical mastery reinforce rather than compete with one another. Another dimension of her impact lay in her subtle reorientation of research priorities. By demonstrating the significance of global symmetries and boundary structures, she encouraged the community to focus attention on previously underappreciated aspects of physical systems. This reorientation did not eliminate existing lines of inquiry. It enriched them, creating a more coherent and interconnected research landscape. The result was a field increasingly attentive to the structural principles that govern both known and yet to be discovered phenomena. Her influence also extended to the culture of intellectual humility. Pasterski consistently demonstrated that the recognition of gaps and limitations in understanding is not a weakness, but an essential component of progress. By modeling this mindset, she encouraged a generation of physicists to approach unresolved problems with curiosity and rigor rather than defensiveness or overconfidence. This cultural shift has subtle but lasting implications for the conduct of science at the highest level. Through this period, her contributions also became increasingly visible in guiding emerging theoretical frameworks. Researchers studying the interface of gravity and quantum information frequently referenced her conceptual models as foundational points of departure. The clarity and coherence of her reasoning provided a stable platform from which complex, multi-layered theories could be explored. Her work acted as a conceptual anchor, helping ensure that subsequent developments maintained internal consistency and physical interpretability. Finally, this phase of her career demonstrates that influence in contemporary physics is not merely a function of individual discovery, but of shaping the collective conceptual landscape. Pasterski's work exemplifies a rare form of leadership, one exercised through framing, clarification, and integrative insight. By providing a structured lens for understanding deep problems, she has permanently altered how the community thinks about gravity, information, and the structure of spacetime. Her impact is not measured solely in citations or awards, but in the subtle yet profound shifts in the questions researchers ask, the connections they recognize, and the frameworks they adopt. In sum, this period of her work highlights the ways in which a single mind, working with clarity, independence, and structural insight, can reshape the practices and priorities of an entire field. By demonstrating the power of rigorous, conceptually coherent reasoning, Sabrina Pasterski influenced not only specific research directions, but also the broader culture of high-level theoretical physics. Her contributions exemplify the principle that lasting influence often comes not from immediate results, but from shaping how others think, approach problems, and perceive the terrain of inquiry. By the time Sabrina Pasterski had established herself as a distinctive presence within the physics community, it became clear that her impact extended beyond any particular calculation or paper. Her influence rested as much on how she approached scientific problems as on the solutions she produced. This broader philosophy of inquiry reflected a deep understanding of the interplay between imagination, rigor, and structure in theoretical physics. Pasterski's mindset exemplified a rare combination. She balanced a willingness to question fundamental assumptions with an insistence on clarity, coherence, and methodological precision. This duality allowed her to engage with some of the most challenging and abstract problems in physics, while maintaining a tangible connection to physical meaning. Central to this approach was her conceptualization of structure as the guiding principle of understanding. In contrast to problem solving that focuses on specific computations or isolated results, Pasterski emphasized the importance of identifying the organizing principles underlying physical phenomena. She regarded equations, models, and technical frameworks as tools for articulating these structures, rather than as ends in themselves. This perspective enabled her to navigate problems of extraordinary complexity, such as those arising at the intersection of gravity, quantum theory, and information, without losing sight of underlying physical narrative. Her intellectual strategy often involved tracing connections across different scales and domains. Where traditional approaches might examine a problem within a narrowly defined subfield, Pasterski sought to understand how it related to broader physical principles. She investigated how symmetry, boundary conditions, and conservation laws manifest across classical, quantum, and gravitational regimes. This integrative vision is crucial because contemporary physics often suffers from fragmentation. Specialists in one area rarely have the conceptual tools to interpret developments in another. By bridging these gaps, Pasterski not only advanced her own research, but also helped unify disparate strands of inquiry. Her work also demonstrated a disciplined interplay between intuition and formalism. Pasterski repeatedly showed that deep conceptual insight often precedes mathematical expression. She relied on intuition to guide the identification of structural relationships, symmetries, and invariants, and then used mathematical formalism to verify and refine these insights. This iterative process is reminiscent of the approaches of historical figures such as Dirac and Einstein, who also treated mathematics as a language for expressing pre-existing conceptual understanding rather than as the origin of insight itself. Another element of her philosophy involved embracing uncertainty as a productive component of research. Unlike approaches that treat ambiguity as a barrier, she saw it as an indicator of where foundational understanding is incomplete. This perspective allowed her to explore questions about spacetime, information, and gravity without being paralyzed by the absence of definitive experimental confirmation. By reframing uncertainty as a guide rather than an obstacle, she maintained intellectual flexibility and avoided the common pitfall of prematurely constraining models to fit existing paradigms. Pasterski's methodological clarity extended to how she approached complex systems. She often began by isolating fundamental features of a problem, stripping away extraneous complexity to reveal underlying patterns. This process of abstraction is a hallmark of foundational thinking. It allows one to identify general principles that remain valid across diverse scenarios. By focusing on core structures, she was able to formulate conjectures and frameworks with broad applicability, rather than producing results confined to highly specific cases. Her work also illustrated the importance of conceptual communication. She recognized that theoretical insight loses its impact if it cannot be clearly conveyed to peers. In seminars, discussions, and publications, Pasterski emphasized precise language and explicit reasoning. She demonstrated that rigorous thought must be coupled with clarity, ensuring that conceptual innovations are accessible and can propagate through the scientific community. This ability to articulate complex ideas without oversimplification amplified the influence of her research. An important aspect of her philosophy involves the recursive relationship between problem and method. Pasterski treated methodology not as a static collection of techniques, but as a dynamic component shaped by the problem itself. The tools she applied, whether mathematical, conceptual, or heuristic, were chosen based on their suitability to elucidate structural features of the system under study. This problem-driven approach contrasts with formalistic approaches, in which methods are applied independently of their conceptual relevance. In her work, method and question were mutually informing, creating a self-reinforcing cycle of clarity and innovation. Her approach also extended to the ethical and cultural dimensions of scientific work. Pasterski emphasized intellectual integrity and humility as foundational to progress. She treated critique not as a threat, but as a necessary component of understanding. In discussions with colleagues, she encouraged openness to alternative perspectives and rigorous scrutiny, modeling a form of collaborative engagement in which the robustness of ideas takes precedence over ego or status. This approach fostered a research culture in which conceptual rigor was valued above performative achievement. Another defining feature of her approach was her sensitivity to the conceptual context of problems. Pasterski repeatedly demonstrated that physics is not merely a collection of equations and experimental results, but a coherent intellectual endeavor in which meaning and consistency are paramount. She approached paradoxes and apparent contradictions not as nuisances to be patched over, but as signals indicating where deeper principles might be discovered. This attitude reflects a broader scientific philosophy. Progress often comes not from confirming expectations, but from carefully investigating the places where theory strains against reality. Her work in gravitational physics exemplifies this philosophy. By examining asymptotic symmetries and boundary conditions, she revealed structural features that had been largely overlooked. She did not simply perform calculations within existing frameworks. She asked why those frameworks behaved as they did and how their limitations might inform the development of new theory. This conceptual focus allowed her to propose insights about information preservation in extreme gravitational environments, highlighting the deep interplay between symmetry, structure, and physical law. Pasterski's philosophy also included an appreciation for the provisional nature of knowledge. She understood that any theoretical model is an approximation of a more comprehensive reality, and she treated this limitation as a guiding principle rather than a source of frustration. By consciously identifying assumptions, domains of validity, and potential sources of inconsistency, she maintained conceptual clarity while exploring speculative or highly abstract terrain. This disciplined openness allowed her to generate novel ideas without overstepping the bounds of reason. A further aspect of her approach involves the strategic use of simplicity. Pasterski often sought the minimal set of assumptions or structures capable of explaining observed phenomena. This preference is not aesthetic alone. It reflects an epistemological principle that simpler structures are more likely to reveal fundamental truths. By focusing on parsimonious explanations, she avoided the proliferation of ad hoc constructs and highlighted patterns that could guide future theoretical development. Her philosophy also emphasizes continuity across scales of inquiry. Pasterski demonstrated that insights about local interactions, such as particle scattering, are not isolated phenomena, but part of a broader structural framework that includes global symmetries and boundary conditions. This perspective enabled her to link micro-level phenomena with macro-level gravitational behavior, a conceptual leap that many researchers struggle to achieve. By maintaining coherence across scales, she ensured that her theoretical models remained physically interpretable and broadly applicable. Another critical feature of her approach is the cultivation of intellectual resilience. Pasterski tackled questions that are inherently resistant to straightforward answers, including paradoxes that had challenged generations of physicists. She treated failure not as a setback, but as an informative signal, allowing her to refine assumptions and adjust her conceptual frameworks iteratively. This resilience, grounded in deep understanding rather than persistence alone, allowed her to explore areas where risk and uncertainty are high, a hallmark of transformational scientific work. Finally, Pasterski's philosophy integrates a long-term vision of science. She approaches problems not for immediate recognition or reward, but with an eye toward enduring clarity and influence. This temporal orientation allows her to prioritize conceptual rigor over expedient solutions, ensuring that her contributions remain relevant as the field evolves. In doing so, she exemplifies a form of intellectual stewardship, shaping the trajectory of inquiry in a way that benefits not only her own research, but the collective enterprise of physics. This first half of her approach demonstrates that Sabrina Pasterski's influence extends far beyond individual results. Her philosophy, combining structural insight, methodological rigor, and conceptual clarity, positions her to address questions that are simultaneously deep, abstract, and consequential. By modeling a way of thinking that balances independence, patience, and integrative vision, she exerts an impact that shapes not only the content of theoretical physics, but also the culture and practice of its highest-level inquiry. The second half of this phase reveals how Pasterski's philosophy translated into concrete intellectual influence, affecting not only the trajectory of her own work, but the approaches of the broader scientific community. Her insistence on clarity and structure allowed her to tackle questions that had resisted conventional analysis for decades. By emphasizing the interplay between symmetry, boundary conditions, and information, she demonstrated that problems previously considered intractable could be approached systematically. This reframing had ripple effects across multiple subfields, particularly in the study of gravitational interactions, quantum information, and emergent spacetime phenomena. Her ability to integrate insights across domains created new avenues for collaboration. Researchers from areas as diverse as quantum field theory, holography, and high-energy phenomenology began to engage with her conceptual frameworks. Pasterski's influence in these contexts was not prescriptive. She did not dictate research directions, but instead offered perspectives that allowed other physicists to identify connections they had previously overlooked. By providing a common conceptual language, she facilitated interdisciplinary cooperation at a level rarely seen in contemporary theoretical physics, where hyperspecialization often limits cross-pollination of ideas. The concrete effects of her influence became evident in the development of new theoretical tools. Concepts she emphasized, such as asymptotic symmetries, boundary encoding of information, and the structural analysis of scattering processes, were adopted and adapted by numerous researchers to tackle long-standing problems. Her work provided both a lens and a guide, a way of seeing previously unnoticed patterns and a set of principles for exploring their implications. This dual role highlights the unique nature of her contribution, which extends beyond calculation into the realm of conceptual infrastructure. Pasterski's approach also encouraged the re-evaluation of methodological priorities within the community. By consistently prioritizing structural understanding over rapid output, she demonstrated that deep, sustained inquiry can yield insights of lasting significance. This had a subtle but powerful cultural effect, prompting colleagues to reconsider the balance between productivity metrics and intellectual rigor. In a research environment where immediate publication is often rewarded over long-term conceptual clarity, her example underscored the enduring value of patience and precision in scientific thought. Another area where her philosophy had tangible impact was in the framing of open problems. By highlighting where assumptions in existing models were implicit or poorly understood, she guided the community to focus on questions of maximum conceptual significance. This guidance did not constrain investigation but sharpened it, helping physicists distinguish between phenomena that could be treated with incremental methods and those that required foundational reconsideration. The result was a collective shift toward more meaningful inquiry, emphasizing understanding rather than mere technical accomplishment. Her influence also extended into pedagogical realms. While she was not primarily an instructor at this stage, her engagement with peers and younger researchers created an informal environment of mentorship. By modeling rigorous reasoning, careful questioning, and clarity of expression, she transmitted intellectual habits that were as important as any specific result. This indirect mentorship contributed to shaping the next generation of theorists, instilling in them an approach to physics that values depth, integration, and principled thought. The philosophy she embodied also reshaped perceptions of the nature of genius and influence in modern physics. Traditional narratives often equate impact with immediate breakthroughs or public recognition. Pasterski's example showed that lasting influence can emerge from a consistent mode of inquiry, a combination of structural insight, careful articulation, and integrative vision. Her contributions revealed that shaping the way others think, by clarifying concepts, connecting domains, and highlighting critical questions, can be as transformative as producing landmark calculations. In her own work, this philosophy enabled her to tackle highly abstract problems with unprecedented clarity. By focusing on the structural aspects of gravitational systems, she could make sense of phenomena that had previously appeared opaque. Her analyses of scattering amplitudes, asymptotic symmetries, and information preservation provided frameworks that not only explained known results, but predicted patterns that suggested new avenues of investigation. This predictive capacity, grounded in conceptual reasoning rather than brute computation, exemplifies the kind of insight that defines enduring scientific contribution. Pasterski's philosophical approach also influenced the interpretation of experimental and observational phenomena. By highlighting which structures and symmetries are essential, she helped colleagues identify the theoretical significance of data and the conditions under which models could be extrapolated. This guidance is particularly important in contemporary physics, where empirical confirmation is often challenging or delayed. Her frameworks allowed researchers to extract meaningful understanding even in the absence of direct experimental access, providing a conceptual anchor for the interpretation of complex phenomena. Another manifestation of her philosophy is the emphasis on continuity and coherence across scales of inquiry. Pasterski consistently demonstrated that insights at the level of particle interactions could inform understanding of gravitational and cosmological behavior, and vice versa. This holistic perspective helped unify seemingly disparate observations, reinforcing the idea that physics is a coherent enterprise rather than a collection of disjointed problems. By modeling this integrative approach, she influenced others to adopt broader conceptual frameworks, fostering more interconnected and resilient theoretical structures. Her engagement with uncertainty and incomplete knowledge further reinforced her impact. Rather than avoiding areas of ambiguity, she treated them as productive sites for exploration. By doing so, she encouraged a culture in which unresolved questions are valued for the conceptual illumination they provide, rather than dismissed as intractable. This mindset helped maintain a climate of intellectual curiosity, where deep puzzles are approached systematically rather than feared or ignored. The cumulative effect of these influences is a profound reshaping of the intellectual landscape in which she operates. Pasterski's philosophy and approach have created ripples across multiple research communities, affecting both the content of ongoing investigation and the ways in which researchers approach problems. By emphasizing structure, clarity, and integrative reasoning, she has contributed to a culture that values understanding over mere output, coherence over fragmentation, and depth over superficial progress. Her impact also extends to how scientific questions themselves are prioritized. By clarifying which aspects of a system are fundamental and which are peripheral, she has helped the community focus on problems of lasting significance. This guidance has far-reaching consequences, shaping not only current research programs, but also the trajectory of theoretical physics for decades to come. In this sense, her philosophy is both practical and visionary, bridging immediate investigation with long-term conceptual development. Finally, Pasterski's approach illustrates a broader truth about the nature of scientific innovation. Transformative influence is often as much about how one thinks as about what one discovers. Her careful attention to structure, her integrative mindset, her commitment to clarity, and her willingness to engage with uncertainty have all contributed to a style of reasoning that advances knowledge indirectly but profoundly. By modeling this approach, she has not only contributed specific insights, but also strengthened the collective capacity of the physics community to tackle foundational questions. Through this lens, it becomes evident that Sabrina Pasterski's philosophy of inquiry is inseparable from her intellectual impact. Her contributions extend beyond individual results into the realm of conceptual culture, guiding how problems are framed, how research is conducted, and how understanding is cultivated. In doing so, she exemplifies a form of influence that is rare in modern science, one rooted in the consistent application of principled, integrative, and reflective reasoning to the most challenging questions about the nature of reality. By the time Sabrina Pasterski had reached the current phase of her career, the scientific community was beginning to recognize not only the significance of her immediate contributions, but also the broader implications of her intellectual trajectory. Her work had established a unique signature, a combination of technical mastery, conceptual clarity, and structural intuition that allowed her to engage with problems of foundational importance. What became increasingly apparent was that her influence might extend beyond the specific areas in which she was actively publishing, into the very ways in which physics itself would be approached in the decades to come. She represents a rare archetype in modern science, a thinker capable of simultaneously navigating technical depth and conceptual breadth, shaping both content and methodology in ways that resonate across the global research community. A central aspect of this influence is her role as a model of integrative reasoning. Contemporary physics faces the challenge of extreme specialization. As fields become more technically demanding, the connections between subfields risk being neglected. Pasterski has demonstrated that the most profound insights often arise at these intersections, where questions from different domains converge and reveal deeper structural patterns. By working across the traditional boundaries of gravitational physics, quantum field theory, and information theory, she has shown that integration is not merely an intellectual luxury, but a methodological necessity. Her trajectory exemplifies how one can cultivate expertise in multiple domains while maintaining a coherent conceptual framework. Her emerging role in shaping the future of theoretical physics is also tied to her approach to foundational problems. Many contemporary challenges, such as the reconciliation of quantum mechanics and general relativity, the nature of black hole information, and the structural underpinnings of spacetime, resist conventional problem-solving strategies. Pasterski's work has demonstrated that progress in these areas depends on reframing problems at a conceptual level, rather than solely on incremental technical calculations. By emphasizing the importance of symmetry, boundary behavior, and information flow, she has provided a toolkit for approaching the deepest questions of modern physics, enabling the community to address issues that might otherwise remain intractable. Another dimension of her influence involves the mentorship of intellectual culture. Although her direct teaching roles may be limited, the indirect effects of her example are profound. By modeling a combination of intellectual independence, rigorous reasoning, and integrative thinking, she has influenced how both peers and emerging scientists approach research. Observers and collaborators alike note that her work encourages careful questioning of assumptions, systematic analysis of structures, and the cultivation of clarity in both thought and communication. These habits, when adopted by others, create an intellectual ripple effect, reshaping not just individual projects, but the culture of inquiry itself. Her trajectory also reflects the evolving role of collaboration in 21st century physics. Unlike the solitary geniuses of the early 20th century, Pasterski operates in a highly interconnected scientific landscape, where the exchange of ideas is global and instantaneous. She has effectively leveraged this environment, participating in workshops, collaborations, and cross-institutional dialogues while maintaining her conceptual independence. This balance, being both deeply engaged and conceptually autonomous, is increasingly recognized as critical for sustaining innovation in fields where complexity demands both depth and breadth. Her example illustrates how modern scientific leadership combines intellectual vision with collaborative agility. In addition, her work underscores the significance of careful abstraction. Many of the problems she engages with involve phenomena that are not directly observable, such as information transfer in gravitational contexts or the structural symmetries of spacetime. Pasterski demonstrates that, in such cases, progress relies on the ability to construct abstractions that are both mathematically precise and physically meaningful. This capacity to navigate between abstraction and intuition enables the formulation of frameworks that can guide future theoretical and experimental work, providing both predictive power and conceptual clarity. Her influence also manifests in the way she challenges conventional assumptions about problem-solving in physics. Pasterski has repeatedly shown that deep understanding requires more than mastery of technical methods. It requires a reflective approach to the conceptual foundations of a problem. By focusing on why systems behave as they do, rather than merely how, she has encouraged a methodological shift. Researchers who engage with her work are prompted to reconsider the framing of their own questions, seeking underlying principles rather than relying solely on computational proficiency. This emphasis on principled inquiry strengthens the capacity of the field to address problems of foundational importance. The implications of her approach are particularly evident in her contributions to the study of gravitational systems and their information content. By exploring the relationships between symmetry, boundary conditions, and observable phenomena, she has highlighted connections that were previously underappreciated. This work has ramifications not only for theoretical understanding, but also for the design of experiments and the interpretation of data, illustrating that conceptual insight can inform both theory and practice. Her ability to integrate these dimensions of physics demonstrates a holistic perspective that is increasingly rare in highly specialized fields. Pasterski's potential legacy is further reinforced by her emphasis on the longevity and durability of scientific ideas. She approaches problems with the awareness that the frameworks developed today will influence the trajectory of research for decades, if not centuries. This temporal perspective encourages a form of intellectual conservatism, not in the sense of avoiding innovation, but in the sense of carefully building structures that are coherent, generalizable, and resilient. By doing so, she ensures that her contributions retain relevance even as technical details evolve or paradigms shift. Her approach also exemplifies the interplay between technical mastery and conceptual audacity. Pasterski demonstrates that significant contributions arise not from either extreme alone, but from their combination. Technical skill ensures that models are accurate, consistent, and operationally useful. Conceptual audacity ensures that questions are framed in ways that reveal previously hidden patterns. This dual capability enables her to engage with problems that are both deep and complex, positioning her work at the forefront of contemporary theoretical physics. Another aspect of her trajectory involves shaping how the scientific community perceives the possibilities of theoretical innovation. By consistently producing work that is both rigorous and imaginative, she challenges the assumption that foundational breakthroughs are rare or unpredictable. Her example shows that with a disciplined approach to structure, clarity, and integrative reasoning, even the most abstract and challenging problems can be approached systematically. This perspective has the potential to inspire a generation of researchers to adopt similarly principled strategies, cultivating an environment where the pursuit of deep understanding is both encouraged and feasible. Her role also highlights the changing nature of intellectual influence in the digital and global era. Unlike previous generations, in which ideas propagated slowly through formal publication and personal mentorship, her contributions have been disseminated rapidly through preprints, online discussions, and international collaborations. This acceleration has magnified the reach of her conceptual insights, allowing them to shape discourse across multiple institutions and research groups simultaneously. Her impact is therefore both direct, through her publications and collaborations, and indirect, through the diffusion of her methodology and perspective. Pasterski's trajectory further demonstrates the importance of resilience and adaptability in modern scientific inquiry. She tackles problems that are not only technically complex, but also conceptually ambiguous, requiring constant refinement and recalibration of assumptions. Her capacity to navigate uncertainty without losing focus or rigor exemplifies the qualities necessary for advancing knowledge in areas where the path forward is inherently unclear. By modeling this resilience, she influences how the broader community approaches similarly challenging problems. Finally, her emerging legacy is tied to her ability to integrate creativity with discipline. Pasterski's work is characterized by imaginative leaps that identify hidden structures and conceptual patterns, coupled with meticulous analysis that ensures these ideas are internally consistent and physically meaningful. This combination of creativity and rigor is a defining feature of lasting scientific impact. It allows her to make contributions that are simultaneously innovative, reliable, and enduring, ensuring that her influence will extend well beyond the immediate context of her work. This first half of the exploration demonstrates that Sabrina Pasterski's trajectory exemplifies the evolving nature of scientific influence in the 21st century. Her work combines conceptual clarity, technical mastery, and integrative vision, positioning her to shape not only specific areas of theoretical physics, but also the broader culture and methodology of inquiry. By modeling a disciplined yet imaginative approach to foundational problems, she has established a path through which future generations of physicists can engage with the deepest questions of reality, potentially redefining both what is possible and what is considered meaningful in the pursuit of knowledge. The second half of this phase focuses on how Pasterski's intellectual trajectory positions her to leave a lasting imprint on both the scientific community and the broader understanding of physics in society. By consistently demonstrating the value of conceptual clarity, structural reasoning, and integrative thinking, she has already begun to shape not only what questions are asked, but how they are asked. This influence extends beyond immediate technical contributions to the underlying methodologies and priorities of research, suggesting that her legacy will be defined as much by the frameworks she has helped create as by the specific results she has achieved. Her approach exemplifies a shift in how foundational problems are conceptualized in modern theoretical physics. Where previous generations often treated physics as a series of specialized domains, her work emphasizes the unity of underlying principles. She illustrates that gravity, quantum mechanics, and information theory are not isolated subjects, but interconnected aspects of a coherent intellectual structure. By framing problems in this way, she enables researchers to see patterns and symmetries that would otherwise remain hidden, fostering breakthroughs that arise from insight rather than mere calculation. This integrative vision also enhances collaboration on a global scale. By providing a shared conceptual framework, she has facilitated dialogue between groups that previously operated in relative isolation. Her work encourages scientists to adopt a common language and to explore connections across fields, strengthening interdisciplinary research in ways that could accelerate progress in areas such as quantum gravity, holography, and high-energy particle physics. Her influence is therefore not just additive, in terms of papers published or results generated, but multiplicative, enabling the community to advance collectively. Pasterski's potential legacy is also tied to her methodological example. Her emphasis on rigor, patience, and careful abstraction demonstrates that transformative contributions are not always immediate or flashy. By showing that deep understanding emerges from sustained reflection and systematic reasoning, she provides a model for approaching complex problems that may inspire generations of scientists to pursue thoughtful inquiry rather than chasing rapid results. This cultural influence on the norms of research may prove as significant as her technical work itself. Her work has already begun to affect the ways in which younger researchers conceptualize their own careers and approaches to physics. Observing her focus on foundational problems, integration across domains, and clarity of reasoning, emerging scientists are encouraged to value the depth of understanding over superficial productivity. Pasterski illustrates that intellectual influence derives not only from what is discovered, but also from how one thinks, how one frames problems, and how one communicates ideas. This lesson has broad implications, suggesting a shift in how the next generation of physicists will approach both research and collaboration. Another element of her legacy lies in her ability to bridge the gap between abstract theory and conceptual intuition. By grounding complex, mathematical formalism in physical interpretation, she makes cutting-edge research accessible and intelligible to a wider audience of scientists. This capacity to translate between abstraction and meaning ensures that her insights can be propagated effectively, fostering a more coherent and comprehensible approach to foundational physics. Her influence is therefore pedagogical as well as conceptual, shaping not only results but understanding. Pasterski's work also demonstrates the importance of resilience in scientific thought. She tackles problems that are inherently resistant to resolution, from information paradoxes in black holes to structural questions about spacetime. Her willingness to embrace uncertainty, carefully test assumptions, and iteratively refine frameworks models an approach in which risk is managed thoughtfully, and failure is treated as information rather than setback. This mindset may redefine expectations for how challenging problems are approached in the field, emphasizing intellectual rigor over immediate success. Her influence is evident in how research questions themselves are framed. By highlighting which aspects of a system are truly fundamental and which are contingent, she guides the community toward inquiries with the highest conceptual payoff. This reorientation ensures that resources, attention, and effort are directed toward problems that illuminate the structure of reality rather than merely producing incremental results. In this sense, her impact is strategic, shaping not only outcomes but the architecture of investigation itself. The broader cultural resonance of her work is also significant. Being recognized as a figure whose thinking exemplifies clarity, independence, and integrative insight challenges prevailing narratives about genius and success in science. In a world often focused on quantity of output or rapid visibility, Pasterski's career emphasizes the enduring value of depth, patience, and conceptual rigor. Her example broadens the definition of scientific achievement, illustrating that lasting influence can be measured by intellectual leadership and the cultivation of understanding, not just by high-profile discoveries. Her work further positions her as a bridge between theoretical exploration and the evolving tools of modern physics. By emphasizing structural principles and conceptual coherence, she lays the groundwork for future advances in areas such as quantum computing, holographic duality, and emergent spacetime models. Researchers who engage with her frameworks gain a roadmap for tackling problems that are otherwise intractable, demonstrating how foundational insight can accelerate both theory and application. Another dimension of her legacy is the subtle but profound effect she has on the norms of scientific communication. By modeling precision, clarity, and careful reasoning, she sets a standard for how complex ideas can be articulated, debated, and disseminated. This influence is particularly important in a field where miscommunication or overly technical presentation can obscure fundamental insight. Her example shows that rigorous thought, when communicated effectively, has the power to propagate and shape intellectual culture. Her trajectory also exemplifies the evolving nature of intellectual leadership in the 21st century. Unlike historical paradigms that valorized individual breakthroughs or singular authority, her influence operates through the propagation of frameworks, ideas, and methodological principles. By guiding the way others conceptualize and approach problems, she exercises leadership that is distributed, cumulative, and enduring. This model may redefine how influence is understood in modern science, emphasizing mentorship, conceptual integration, and structural clarity over personal renown. The cumulative effect of her work, philosophy, and example suggests that her impact will persist well beyond the current generation of physicists. By emphasizing the unity of principles across domains, modeling rigorous and reflective inquiry, and shaping the culture of collaboration and problem framing, she establishes a foundation upon which future advances will build. Her intellectual fingerprints are therefore likely to be detectable not only in specific results, but in the methods, questions, and conceptual structures adopted by the broader community. Finally, her trajectory illustrates a broader lesson about the evolution of science itself. In an era defined by specialization, rapid technological change, and increasing abstraction, Pasterski's approach demonstrates that enduring contributions arise from the combination of deep understanding, integrative vision, and disciplined creativity. Her work is a reminder that the most significant scientific advances often emerge not from isolated brilliance, but from sustained, reflective engagement with the fundamental structure of reality. By exemplifying this mode of inquiry, she provides a template for the next era of theoretical physics, one in which conceptual clarity, methodological rigor, and collaborative integration define the path forward. Through this lens, Sabrina Pasterski emerges as more than a remarkable individual researcher. She represents a paradigm for how scientific thought can evolve in the 21st century, rigorous, integrative, and enduring. Her influence spans technical contribution, methodological innovation, and cultural shaping of scientific practice. By demonstrating the power of thoughtful, structured, and visionary inquiry, she positions herself not merely as a participant in contemporary physics, but as a guide for its future trajectory, shaping how questions are posed, how research is conducted, and how understanding is cultivated for generations to come.